We're going to discuss the addition and subtraction property of inequality. We're going to let A, B, and C belong to the set of real numbers. Okay, those are the only two symbols that I really want you to learn. Now I'm going to do both properties at the same time, well, on the same line anyway. So let's discuss the addition property. If A is greater than B, then A plus C is greater than B plus C. So let's talk a little bit about what they're doing. If this is true that A is greater than B, say 10 is greater than 1, then if I add the same value to both sides, it's still true. This side is still greater than that side. Let's look at subtraction property. If A is greater than B, then if I subtract C on both sides, this should still be true. If I have 10 is greater than 1, then 10 minus some number is still greater than 1 minus some number. Always. We're going to solve and graph the inequality. Then we're going to give the interval notation. Let's look at our first inequality. We have m plus 3 is greater than 7. I need to solve for m. I need to get m by itself. So if I circle m, whatever I didn't circle has to move. So since 3 needs to move to the other side of the problem, that means I'm going to use the other sign, which is subtraction. Because inequalities act like an equal sign-ish. So by subtracting 3, I am getting m by itself. I get m is greater than 4. Now that m is greater than 4, we can graph this inequality. I already have my test points on the graph, negative 100 and 100. And again, you can use your test values. I am plugging negative 100 in for m, and I am plugging 100 in for m. We just now have to determine true or false. Is a negative number greater than a positive? And the answer to that is no, that is false. So this side where the negative 100 at is false. If we look at this one, they're both positive, so I can't say is a positive greater than a positive. Now it depends upon the number. Is 100 greater than 4? Yeah, I think we agree with that. That's very true. What do we do next on our graph? We shade our true side from our number all the way and past our test point. We go all the way to the arrow. From here, we just need to determine what type of symbol we use on 4. Is it parentheses? Is it parentheses or is it brackets? If you have this symbol here, greater than or equal to, these two equal signs help you form your bracket. So inequalities like this, greater than or equal to, you could even do less than or equal to, these have brackets. Because you're allowed to put an equal sign on this tick of the number 4. We were given a greater than symbol. If we have greater than or less than, that means that we have to use parentheses of some type. So that means no equal sign can be formed on my graph. I have to use parentheses. And again, the parentheses must touch the tick that you found right there. And the parentheses is what I want you to use. We are not using open circles at all. No. Now that you have your graph already filled out, and it is correct, we need to do what's called interval notation. Interval notation means where do we start at for our shading and where do we end at for our shading. Now I'm just putting parentheses just to show you, but those parentheses can change depending upon our problem. But where does it start at and where does it end? Well, for our graph, where does the shading start at? It starts at 4. So I'm going to put down the number 4. So I'm going to write the number 4, and then I'm going to write where does my shading stop at. And it stops at this arrow, and that arrow represents positive infinity. Positive infinity, or any infinity, you just follow the curve of the infinity, and that is a parentheses. When you look at 4, the symbol we placed on the 4 was the parentheses. This is our interval notation. What this means is that 4 is not a solution to this problem. It means that it starts from 4, but not including 4. And then it goes on forever. This contains all of your answers on the graph that you just shaded. Shorthand notation for every single answer. Let's look at a new problem. I have 12 plus y is less than or equal to 3. Again, the idea here is to solve for the variable. And one of the cool things about adding and subtracting is that your inequality sign never changes. It always stays put. It never switches. It doesn't change opposite directions. It stays put when you add or subtract, which is great. So what am I going to do first? Well, if I want to get y by itself, circle it, and everything else must move on that side. In this case, I'm going to be subtracting 12. And again, I'm subtracting because I'm moving it over to the other side. So if this is 12, a positive 12, I'm using the other or opposite sign, which is negative. 12 minus 12 is 0. And I have y is now less than or equal to, again, the sign does not change. And we have 12 minus 3 is 9, but 12 was larger, and I use that loosely, and it was negative, so I give it the negative on the 9. Now that I have my answer, it's time to graph this. And I'm going to graph it using my test points in for y. Negative 100 is less than or equal to negative 9. 100 is less than or equal to negative 9. So here's my negative 9, that's all I need. And I just need to know which one's true, which one's false. That's a very good question. Again, when it comes to negative numbers, which one is closer to 0? Negative 9 is closer to 0. That means negative 9 is greater than or equal to negative 100. This is true. So that means that negative 100 is smaller. So let's look at it the other way. Is negative 100 less than or equal to negative 9? Realizing this is small and this is large. Can a small number be less than or equal to a large number? That is true. So the negative 100 gets the true side. Do you have to go any further than that? No, you don't really have to. Once you get a true, you can stop. And you can shade the true side. But I'm going to do the other side because I can. Is a positive less than or equal to a negative? That's all you need to do when you have opposite signs. Is a positive less than or equal to a negative? Nope, that's false. And of course we knew that this side was the side to shade because it was true. And again, shade all the way up to the negative 9, shade all the way to the arrow. And now our question is, do we use bracket or parentheses? Well, since we have a less than or equal to, we can form an equal sign on the tick mark of negative 9, and that forms our bracket. So using our interval notation, it's going to be very simple. Where does our shading start at? And again, it's always a start and then an end or a stop. So when we do this, where's our start at? It's at negative infinity. Where does my shading end at? It ends at negative 9. Once you've got those two, then it's just time to put in your symbols. Infinities, you always follow the infinity symbol. It's parentheses. And negative 9, if you do it right, was a bracket. Voila. And that is your interval notation. Negative 9 is a solution to this problem, so negative 9 is included as part of our answer. Okay, new example. We have 3 plus 9b is greater than 8b minus 5. Now again, when you do these inequalities, please, please, please do the variables first. It will make it less confusing. So I am dealing with the b's. Now you're seeing that I'm subtracting 8b, and the reason for that is 8 is smaller than 9. So I'm going to move the 8b over to the other side, and because it was a positive 8, I'm going to subtract 8 on both sides. Again, this inequality symbol acts like an equal sign-ish. 8b minus 8b goes away. And I'm left with 3 plus 1b, because 9 minus 8 is 1. Again, this 1 is optional. You don't have to put it there, but if you do need it, by all means, leave it there. And this is greater than negative 5. Now that I've got my b with a 1 in front of it, and I've only got one b in the entire problem, then it's time to get this b by itself. And what I'm going to do is subtract 3 on both sides. Whatever I circled stays, whatever I did not circle is the one that moves. So I'm going to subtract 3 on both sides. By subtracting 3 on both sides, I get b is greater than negative 8. You can choose to have the 1 here or not the 1. Again, that is totally optional. It's totally up to you. It is time to graph. Again, I'm using my test points on the graph to help us out. If you understand the test points and you don't need them, then you don't have to. It's quite all right. You don't have to use them, but I find it helpful for a lot of people. What I'm going to do is, again, I put my answer here. I got my test points on the graph, and I'm going to put in my test points into the b is greater than negative 8 equation. The negatives are the ones that give most people the headache. One more time. Who is closer to 0? That is negative 8. That means 8 is the bigger number and 100 is smaller, because the further away it is from 0, the negatives, the smaller the number becomes. So 8 is bigger. So can you say a small number is bigger than a bigger number? Can you say a small number is greater than a bigger number? No, you really can't. That is false. So negative 100 is no way greater than negative 8. Looking at this one, opposite signs. So we just read it. Can a positive be greater than a negative? Oh yeah, big time. Not a problem. So what we're going to do is I'm going to put my false and my true side on there, realizing that I shade the true side. Again, this is how I do it. You don't have to do it my way, but my shading's correct anyway. You don't have to label it true and false. And because it is greater than or less than, those always get a parentheses. Now that I have my graph filled out, it's time to do interval notation. Again, interval notation is about a start and a stop, start and an end. Where does my shading start at on the graph? It starts at negative 8. And the shading continues to this arrow called positive infinity. You have the infinity symbol here. You follow the sexy curve right here. It forms a parentheses, so I'm forming a parentheses right here. Negative 8, according to our sign, says you have a parentheses on that as well. This is our interval notation. These are all the answers to the shaded portion of our graph. Negative 8 is not part of the solution, but again, we did need a starting value. So we're starting at negative 8, but not including negative 8 as our answer to this problem. Got a gorgeous problem right here, folks. It's a double star, so something interesting is happening here, or it's hard. So let's talk about this. I've got m's on both sides. I need a variable on one side of this problem only. So what I'm going to do is look at my m's. I see a 4 and a 5. The 5 is larger, so I'm going to move the 4m over to the other side. How do I do that? If this is a positive 4m and I'm moving across an equal sign, I'm going to change the sign of the original problem. So I'm going to change it from a positive 4m. I'm going to subtract 4m on both sides. Now I have 16 is less than 1m, again this one is optional, plus 17. Notice there's only one variable in this problem. If I circle it, this is going to stay, this 17 must go. So what is the opposite of a positive 17? If I move it across the equal sign, the inequality symbol, I'm going to subtract 17. Opposite sign, because I'm going on the opposite side. 16 minus 17, knowing that gives you 0, gives me 1. And not only 1, but it's a negative 1, because 17 is larger, so 17 minus 16 is 1. 17 is the larger number, and it's negative, so my answer gets the negative sign. Negative 1 is less than m. There's a positive 1 in front of it. M is all by itself. We solved for M. Now that we solved for M, we can go ahead and graph it. There's that negative 1 that keeps showing up all the time. And I put my test points on it. We're good to go. And I'm going to put my negative 100 and positive 100 in the inequality that we just formed, the simplified one. Negative 1 is less than m. And let's go ahead and work this. Again, remembering, the closer it is to 0, the bigger it is. So can a bigger number be less than, again, the further away a negative is, the smaller it is. Can a big number be less than a small number? No, that is false. It turns out negative 1 is greater than negative 100. Can a negative, again, opposite sign, so I'm just going to go with signs. Can a negative be less than a positive? Yes, a negative can be less than a positive, that's true. So again, this is false and this is true. I'm going to label my graph and shade the true side. Shading all the way to my lovely arrow, shading up to negative 1. And understanding, since I have a greater than or less than symbol, I am using parentheses which face the shaded region. Awesome. Now that I have this, it is time for interval notation time. Interval notation. One more time. This is a start. And then where does my shading stop at? So looking at the graph, going from left to right, my shading starts at the number negative 1. And my shading ends at this arrow sign, meaning positive infinity. Again, follow the curve of your infinity. We are using parentheses. Looking at negative 1, according to our graph, and we did do it correctly, it deserves a parentheses. This is our interval notation. All of our answers, again, are in here. The only number I cannot use is negative 1, because parentheses says negative 1 is not included in this problem. But again, I needed a starting number to begin with. Parentheses tell me negative 1 can't be part of that.